Welcome to yet another exercise. So today we are going to be talking about physics 102, and we are going to be discussing electric force, electric fluence, electric intensity, electric potentials, and others. So before we solve an exercise under this electric force and its components, we will love to derive some equations and discuss their relationship, because when we understand those equations, we will be able to use it. Electric force of attraction or electric force of repulsion. And we know that this electric force of attraction or the repulsion says that force is equals to uh, K, which is a constant, Q1, Q2 over R squared. So let's keep this one as equation 1. This is electric force of attraction between two charges. Whether if the charges are positive, if it is attraction, meaning it is positive and negative. But if it is between positive, positive or negative, negative, it is either repulsion. That should be force of repulsion. Now, let's move further and we talk about electric intensity, electric field intensity. Electric field intensity, we have it, which is denoted by E, is equals to the force divided by charge. So when we, let's call this one equation 2, when we put at electric fluence, under the electric fluence, and the electric fluence is denoted by like phase angle is equals to the of product of electric field and the area, electric field and the area. So this one equation 3. So according to Guy's law says that the electric fluence is the charge divided by permittivity naught. It is the charge divided by permittivity naught. This, let's call this equation 4. That means at this point, where the Guy's law has given us another equation, which is charge divided by permittivity naught, is equals to E dot A, which is equals to Q over E naught. Now we move further and we talk about electric potential. Electric potential. And we know that electric potential is denoted by V. It is the work done over charge. So for me to know the electric potential of a particular component, we need to know the work done by the component against the charge, against the flow of the electricity. So we have it as the electric potential. Its potential is the work done divided by charge. And at this point, we know that, let's break this down. We know that work done, if, let's bring it here, that if work done is equals to force multiplied by distance. So we can actually substitute this work done into, equation, let's call this equation 5, and let's call this equation 6. We can actually substitute this work done into equation 5, meaning we're going to have something like electric potential is equals to work done, force times distance divided by charge. And this, we remember that our F, force of attraction or force of repulsion, is equals to, from equation 1, is equals to K Q1 Q2 multiplied by the distance D over the force, which is R squared, multiplied by our Q. Now, the question, let's interpret this better way. Our force brought about all this. This is what our force brought about. And we now replace our d over q, which is d over q. I agree with you on that. So therefore, let's take one of these q, take away one of these q. And the r here is the distance between q1 and q2. And this is also a distance. So one of these will also take one of these. So what we are left here is another equation for potential difference. The potential difference of electric. The electric potential difference is equals to k kq over r. Kq over r. So let's call this equation. Let's call this equation 7. Remember that we have electric field is equals to force over charge. Electric field is equals to force over charge. And also, we know that electric potential is equals to work done over charge. Work done over charge. There is a relationship here. So if there is a relationship here, let's take this out. We can actually have this to be that electric field intensity is equals to force over charge, and thereby we have that our electric potential is equals to force multiplied by distance over charge. So therefore, if we look at this, it means that we have force times distance. This force times distance brought about this. Right? Now, at this point here now, let's make Q the subject of formula here. Let's make Q the subject formula. If we are making Q the subject formula here, or F the subject formula here, we are going to be having that F is equals to EQ. Now let's substitute this F into this equation. Therefore, we are going to have V is equals to EQ multiplied by EQDX. EQD, meaning our F we substitute our F to be what? EQ over D over what? Q. So therefore, Q we cancel Q. So therefore we have electric potential is equals to ED, which is electric field intensity multiplied by distance. So and therefore, so also, now let's call this equation 8. And so therefore, making E the sort of formula, we can have it that our electric field is also equals to V over D. Let's call this equation 9. Now with this equation, all these equations 1 to 9, we'll be able to solve any question given to us.